Hello, welcome to my channel Devops with Prasanna. This is day 15 in Learn AWS in 30 Day series. So today we are going to talk about the database tier of our quiz application. So if you see, we already saw the front end tier, back end tier, and this is going to be the database tier. And I have a very interesting demo for today's session. So this is the demo. As we discussed in the previous section, we are going to have the same three lambdas, but this lambda is going to use DynamoDB tables now. So there are going to be two tables. One table stores information about the quiz. So it contains information like what is the title of the quiz, what are the questions, what are the answers. And the next one is to store the score related information of the user. So just to give the overview of the functionality, like when the user logs into the application, he'll be given with a list of quizzes. Each and every quiz corresponds to a session. So for example, for day 11, logging and monitoring, there will be a quiz for it. So once the user selects a particular quiz, he'll be provided with a list of questions. And the user can answer the question and he can submit the answers. So once the answer is submitted, it will be sent to the compute score lambda, which will calculate the verify the answers and compute the score, and then saves the information in quiz score table. So this is what we are going to do. And to make things slightly complicated, I made the questions as list of map and answers as a map. So we'll see some advanced data structure also. Cool. So along with this interesting demo, there are some useful topics which we are going to talk. One useful topic is about the pricing part of DynamoDB. We are going to talk about RCU, and then WCU. And then we are going to do a very short exercise on how to compute these capacity units. Cool, I'm very much excited. Let's get started. Okay, so we'll see the overview of DynamoDB. So DynamoDB is a very special database in AWS. The reason for that is it is NoSQL, it is serverless, and it is a proprietary database from AWS. So which means you will not find this database in any other cloud provider. And to understand DynamoDB in a better way, I thought we can compare it against RDBMS, which is a relational database. And then we can see how DynamoDB differs. So the first one is DynamoDB is schemaless, whereas RDBMS tables are having well-defined schema. So what is meant by schema? You might be aware of rows and columns in RDBMS table. So the column is always fixed, but in case of DynamoDB, it is not fixed. So only the primary key is fixed and all the other things are optional by default. So each and every row can have different columns in it. So that is schemaless. And it is a key value pair compared to the traditional row concept which we see. But when we see the AWS console, we'll try to visualize this in the row format itself. But you have to understand DynamoDB is a key value pair. The second one is horizontal scalability. So with RDBMS, the maximum scalability which we can achieve is the read replicas, which we already saw in the RDS session, which means we can have more number of instances that will be served only for the read purpose. But in case of DynamoDB, horizontal scalability is possible, which means if you have a lot of data, you can add more machines to the cluster and it will know how to scale the data. So that is horizontal scalability. The next one is HA mode by default. Because DynamoDB clusters will have instances in different AZs and it is managed by AWS itself. So it is having HA mode by default. In case of RDBMS, you can achieve HA mode, but you have to do some configuration for that. The next one is minimum latency. So DynamoDB follows the concept of partitioning. For each and every data we store, there is a partition key and data will be sent to only to that partition. And within that partition also, we'll be having something called a sort key. Maybe just to explain this in a better way, for example, let's assume this is our table. Okay, and it contains multiple partitions. In this case, it's having 3 partitions. Okay, if you want to put an item into the table, first it will go through something called as hash function. And this hash function determines what is the partition ID is. And it will place the item within that partition ID. And it will use a sort key to sort the partition also. So it will be placed in the corresponding place. And when we want to do a lookup, it will be like very fast because it will again do the hash computation. It will go to the corresponding partition and then it will get the value for it, which means it's going to be like really fast in fetching the data. We'll see the exact numbers of the latency and things like that in little bit time. Cool. And the same thing can be achieved using RDBMS using a concept called sharding, but it is slightly more complicated. But it is coming by default in DynamoDB. The next concept we have to understand is RCU and WCU. So as we discussed in the introduction session, like this is a serverless database, which means we are not going to have a fixed cost always. We are going to pay to AWS based on the usage. And how to determine the usage? It's based on this RCU and WCU. So we are going to discuss this concept in detail in few minutes. Okay, there are no joins. So again, DynamoDB is a NoSQL database, which means you can't have joins. So how you can mitigate that join is, if you want to have a join, then it means like you should have the data in that corresponding table itself. So in our case, for example, if it's going to be RDBMS table, we'll be having a separate table called questions, and we'll be having a separate table called quiz, and we'll have a join between them. So this is how the structure would be. Quiz and then questions. This questions table will have a quiz ID, which will correspond to a row here. But because DynamoDB is a NoSQL database, we just added the questions array into the quizzes table itself. So that's how like we should always structure the schema. And then as we discussed already, it's a AWS proprietary solution compared to RDBMS options like Postgres or MySQL, which is an open source solution. Cool. I think like this summarizes the DynamoDB compared to RDBMS. Before going into explaining this table structure, we'll talk about the DynamoDB terminologies. Tables. This is where we are going to save all the data. So it is called as table in DynamoDB. And for each and every table, there is going to be a primary key. So this primary key consists of 2 components. One component is called partition key. The other component is called sort key. This sort key is optional. This is what we quickly saw in the sort here. So for each and every table, we'll be having partition key and sort key. Partition key will determine which partition the data should go into, and sort key determines how the rows should be sorted within the partition. That's what it's going to do. Then we are going to talk about item. So this is equivalent to row in RDBMS. And attribute. This is equivalent to column in RDBMS. Because we are in DynamoDB, we'll going forward, we'll refer the row as item and column as attribute. Okay. Cool. So we understand the basic terminology of DynamoDB. Now coming to the 2 tables which we are going to create. In the quizzes table, quiz ID is going to be the partition key. And there is no sort key in this case. We are going to have title, a string. We are going to have questions, which is a list of map. Here, the entries for map is question ID, type, and options. And we are going to have one more map, which is the answers. This is the actual answers. Okay. And for the quiz score table, we are going to have user ID as a partition key and then quiz ID as a sort key. So this combination should always be unique. This is similar to the RDBMS world. So the constraint which it imposes is the user can take quiz only once. If he tries to take the quiz again, this schema will not support for it. And we'll have the score as a string percentage and then the time taken. The catch here is DynamoDB doesn't have the date column. So we'll be storing this time as a string there. Cool. Now we saw the schema. We'll try to create the tables in DynamoDB and then we'll insert sample data. Okay. So we are in the DynamoDB homepage. From here, we can go to tables. There are no tables. First, I'm going to create the quizzes table. The partition key for quizzes table is ID, which is a quiz ID. And the sort key is not there, it's optional one. And you can see by default, DynamoDB comes with provisioned capacity, which means 5 RCU and 5 WCU. This is what we are going to pay to AWS. Don't worry, we are going to discuss in detail about provision capacity and on-demand capacity. But as of now, I'll change this to on-demand. Okay, cool. So this is fine. Encryption at rest. This is something which we saw at the RDS session itself. So we are going to encrypt the data which will be stored in DynamoDB. Cool. And then we'll create the table. Okay, let it create. The next table which we want to create is quiz score. Let's create table. Quiz. Score. The partition key is going to be user ID, which is a string. Sort key is going to be the quiz ID. Okay. Again, in this case also, I'm going to change this to on-demand capacity. Okay, so now we have created our two DynamoDB tables. I'll just refresh the page. Super. So two tables are available now. We are going to insert few sample data into these tables. So I have the sample data here. This will also be committed to the GitHub repository, so you can check that one. So just to give you the understanding of what data it is going to be, for the quizzes table, the ID is going to be 1 and the title is going to be day 11 logging and monitoring. So these are the 3 questions which we are going to have. CloudWatch does not support centralized logging and the options are true or false. It's a multi-choice question. The next one is CloudWatch provides support for logging, monitoring, alerting and tracing. Log streams are subset of what component in CloudWatch? So log streams are subset of log groups. So this is quiz number 1, which is for day 11 session. And there is going to be quiz number 2, which is for day 12 session. And it's going to have 3 questions and corresponding answers for it. Okay, so we'll start creating the data for it. I'll go into quizzes. This is the quizzes table. And you can see there are various options available. What we are going to do is explore table items and then create item. The partition ID, partition key, which is the quiz ID. It's going to be 1. I'm going to add a new attribute. This is title. I'm going to add one more attribute, which is questions. And this question is going to be a list. And the type of this, the value in that list is going to be map. So this is a little bit complicated part. And this map is going to contain the question ID as a string. It's going to be question underscore ID. Question ID is going to be Q1. Okay. The next field is going to be question. The next field is going to be type. The next one here is the list of options, which means we are going to have a list again. It's going to be options. And it's going to have a string, which is true. It's going to have one more string. It's going to be false. So this is the index. So the 0th index is having the value as true. First index is having the value as false. Okay. So this is the 0th item. Similarly, we are going to add other questions also in the index 1 and then index 2. Just for the sake of the time, I'll create this in offline and then I'll explain you the things. Okay, so I'm done with filling the values. This is the second quiz which I filled. So I can see the ID is 2 and the title is Day 12 Serverless Application AWS. Serverless Application AWS. And the questions, there are 3 questions, which means this question is an array. It contains 3 map in it. Each and every item here is an entry in the map. So questions, if I expand this, you can see there are 3 items. Each and every item here is a map. So if I expand this further, you can see there is a question ID, which is Q1. And then there is a question, and there is a type, and then there is an option. Again, this option is a list. Maybe I think I should show this one. So option is again a list with 2 values. So if I expand this, you can see there is 2 values. This is for question 0. And similarly for question 1, there are like question ID, question type, and then options. Similarly for the last one, question ID is there, question is there, type is fill in, which means it's a text field. And it's not going to contain any options. So we can just leave that one. Cool. So we could able to create this, and we also created the answers, which is a map. So for each and every question with the ID, this is going to be the answer for it. So I'll create the item. So you can see like we have 2 quizzes now with 3 questions each. Cool. We have created the DynamoDB tables with the sample entries also. We'll update the Lambda functions. The first one is get all quizzes. Previously, we were getting the information as in a static way. It is not connecting to any database. So we'll update the code with this one. So we are going to use a library called Boto3 and talk to DynamoDB table and get all the entries, all the quizzes available, and we'll give it to this API. Okay. And this is going to use a method called scan table. We are going to see about different operations like scan table, get item, put item, data, but just keep this in mind. Scan always uses pagination. So we'll fetch page by page and then put all the items inside the quizzes array, and we'll return this array. So I'll copy this code. Okay. And I'll see what is the event we have. So there is no inputs to be passed. Okay, this is cool. I'll deploy my changes. I'll say test. Okay, so it's saying like it couldn't find a key called a name. We'll quickly see what it is. Yeah, because we have to use it something called title. Okay, so this is something which you should understand. Like even though I changed this to title, I need to do a deployment. Then only the Lambda changes will be taken into effect. So I'll do a deployment, and if I do a test, okay, this is working fine. So I could be able to get 2 quizzes for one for day 11, one for day 12. There is one more change which I did, which is to add the IAM role. Maybe for the next Lambda, I'll remove that IAM role permission, and then I'll add it back. So if I'll remove this permission. Okay. From the compute score. Cool. So now I'll go to the next one, which is to get questions for a particular quiz. Again, this is we are getting it statically. Now we'll try to get it from the DynamoDB table. So this is the source code for it. This is actually using the get item. If you remember, for the quizzes table, ID is a primary key. So it is mandatory to pass the primary key and get the values. So we're getting the value and we're just getting the questions and title from it and then returning it back as a response. Okay, this looks good. I'll do a deployment and then I'll do a test also. Okay, this looks great. So we could able to get values for the day 11 quiz. So there are like 3 quiz questions which we have. Now we'll go to the third one. This is slightly complicated logic because we have to fetch the questions answers from this quizzes table and then we have to compare this against the answer submitted by the user. And based on the answer, we'll compute the score also, score and percentage. Once the score and percentage are computed, we'll save that information in score table along with user ID and quiz ID. Okay. Again, the source code is available in GitHub, so you can feel free to check this out. Okay, so this got deployed. If you remember, I removed the permission from this role because by default, Lambda will have permission only to CloudWatch. It will not have any permission to access the other resources. For example, DynamoDB is another AWS service. So we have to explicitly give permission for this Lambda to access the values. Yeah. So you can see like there is an access denied exception. And this is coming for this particular role. And this is the role which is attached to this Lambda. So what we are going to do is, I'll go to IAM, I'll go to roles, and then I'll search for this role. Okay, here I'm going like we currently have only permission to access logs. Now I'm going to add one more permission, which is to access the DynamoDB. So I'm going to give DynamoDB full access because we are going to read and write in DynamoDB. Okay, so this got added. Now if I go to my Lambda function and if I test it again, cool. So you can see the Lambda function worked fine, but the score is 0. Maybe we'll quickly see why the score is 0. We got the values, actual answers, and the expected answers. Okay, if I see the test data for Q1, yeah, so we are giving the values 0 and 1, but ideally it should be false, it should be true, it should be log groups. I'll save this event, and then if I test it again, cool, I could able to get 2 questions correct, and the score is 67. So this looks great. Now the next part is to use this from the API gateway. So because the API gateway is going to talk to Lambda, we don't need to make any changes in the API gateway. We can just use the older methods itself. So if you go to Postman, if I go to my API, I can just invoke this API. Yeah, you can see the response status code is 200 and we could able to get back both the quizzes. And if I want to get it for one particular quiz, I can go to this one with the resource called quiz. Cool. So we could able to get 3 questions for this particular quiz. If I want to submit my answer, I can go to compute score, quiz ID Prasanna. Again, I'll change this one. I'll change this to false, or I'll change this to true, and then the log groups. Just a point to be noted, if I go into my DynamoDB table, if I go to my table called quiz score and explore table items, there is already an entry which is coming from a test data. But if I try to submit the data again, this will fail because there is already a user ID, quiz ID combination available If you remember, I can't submit the same data again because this 2 forms the primary key. So I'm going to delete this data. Okay, we can see read capacity units consumed is 2. We'll talk about this in a bit. Cool. Now I'm trying to submit this one. Okay, so I got the score as 3, which is 100%. And if I go and refresh the data, I could be able to see the results. So it will contain information like who's the user ID, what is the quiz I attended, what is the percentage, what is the score, and when I when I took this quiz. Okay, so this is the demo which uses API Gateway, Lambda, and DynamoDB. Yeah. Okay. So now we'll talk about one of the most important topics in DynamoDB. It is the pricing. DynamoDB is not a normal database, so it is not priced based on the number of hours the database is running. Instead, it is priced based on the read or write capacity. So this is the pricing model. First, we'll talk about the provision model because it's a slightly complicated one. Then we'll come to the on-demand. So provisioned model. What is meant by provisioned model is, this is a guarantee which you are giving to AWS that you are going to use this much capacity in terms of a read unit and write unit. So AWS will be charging you against that guaranteed amount. For example, if you say I'm going to use 5 read capacity unit and then 10 write capacity unit, which means on a monthly basis, you are going to pay for 5 RCU and 10 WCU. Okay. Now, what is meant by WCU and RCU? First, we'll see about WCU with an example and a very short exercise. So, WCU, RCU calculation. Okay. One write capacity unit. What this means is, one write per item, the size of this item should be 1 kilobyte. Okay. So, this is a calculation. For example, we'll take the first case and we'll try to calculate how many write capacity unit we are going to need. Okay. So we say like we are going to use 50 items per second. That is the write we are going to make into the DynamoDB table. And each and every item size is going to be 2 kilobytes. If you remember, once we insert the data, we got the information like this is a read capacity unit, it got consumed. So that's how things are going to be, like everything is going to be in capacity units. So for 50 items per second and each item is having 2 kilobytes, what is the WCU? Cool. So 50 items, which means writing one item consumes 1 WCU. So 50 items consumes 50 WCU. Okay. Each and every item is having 2 kilobytes. But for each and every 1 kilobyte, there is going to be 1 WCU, which means each and every item is going to take 2 units. So 50 into 2, 100 WCUs is what we should assign to that DynamoDB table. Okay, for this particular example. WCU is a very simple one, but RCU is slightly complicated one because there is one more concept involved. Whether it's going to be strongly consistent or eventual consistent. So what is meant by these two concepts? So this is very important concept to understand in distributed systems. Okay, let's take the example of 3 servers. Okay, S1, S2, S3. So if you remember, we talked about clusters and we talked about horizontal scalability, which means you can easily add one more node to the cluster and DynamoDB could be able to share the workload among these 4 nodes. That is the idea. Okay. So let's say we are trying to write some data into S1 and there is always a concept called replica, which means even if this node goes down, things will not be completely dark. We'll have a replica in some other nodes and we could be able to read that. Okay, so that is the concept of replica. Let's say we are going to write item 1 to S1 server. Okay, and the replica of partition is available in, let's say, like in S2 and S3. Okay. So whenever we write this item to S1, if it immediately sends back the acknowledgement saying that, okay, write is successful, and then as a asynchronous operation, it will write to the S2 and S3 partitions. This type of method is called as eventual consistency. Okay. What this means is you are writing to server, you are immediately getting back the acknowledgement once the S1 write is complete. But eventually all the other servers will be updated. That is the idea. The problem in this case is, for example, you are writing, you are getting back the acknowledgement, but you are trying to read the data immediately. But this read request is going to server 2. If you read the data, there is a chance like you might get the stale data. Stale data in the sense it's a old data because the async operation is not completed. Okay. So this is a problem with eventual consistency, but the advantage here is the writes are always very fast because it just has to write to one server and then you'll get back the acknowledgement. Cool. Now we'll see about the strong consistency. It is the opposite of this. So whenever you write an item, the acknowledgement will not be sent back immediately. Okay. Instead, this server will send the information to S2 and S3. Once both the servers respond, then only it will send the acknowledgement. Okay. In this case, the advantage here is after getting the acknowledgement, you are trying to immediately read the data from S2. There is a guarantee like it will always be the proper data. It'll never be the stale data. It'll always be the good data, which means the latest data available. But the problem here is each and every write will be time consuming because it has to send this information to other servers, get back the acknowledgement, and then only send the acknowledgement to the user. So this is the advantage and disadvantage in strong consistency and eventual consistency. This concept is not specific to DynamoDB alone. In any distributed system, this is what's going to happen. Okay. But the point to be noted here in DynamoDB is there is variation in the read capacity unit for write consistency and eventual consistency and strong consistency. So for example, for one RCU will be consumed in strong consistency model for every read per second with 4 KB in size. Whereas in eventual consistency, it is slightly slightly cost effective. We can have 2 read per second with 4 KB of size because eventual consistency is going to use a async model. So we can have 2 read per second. To understand this with an example, let's say like we want to have a strong consistency read. Okay. We want to read 20 items per second. Each item size is 4 KB. So what is the RCU we are going to consume? So 20 items per second. For one RCU is 1 read per second. So which means it's 20 RCUs. And one item size is 4 KB. We want to have, and the allowed limit is also 4 KB, which means this is fine. So 20 into 1. So we want to have 20 RCUs. So this is the, So we are going to have 20 RCUs. So this is the read capacity unit. Cool. So I hope you understand this concept in a proper way. This is how the pricing works in DynamoDB for the provisioned model. If it's going to be on-demand pricing, it is nothing but you're not giving any guarantee to AWS. You're saying whatever request comes in, please charge me according to that. But this on-demand is always on a higher cost. Like the RCU and WCU for on-demand will be slightly more than the provisioned capacity. But this is a simpler version. So in our use case, when we try to create the quizzes table, we try to create it in on-demand provision capacity. Because our usage is going to be very, very less. We don't want to guarantee anything to Amazon. This is what I want to discuss about pricing. Okay, so we reached the end of the session. Hope you liked the demo. and the concepts which I explained in DynamoDB. So if you have any questions or feedback for me, please let me know in the comments. I'll be reading all the comments. Yeah, see you tomorrow. Happy learning. Bye-bye.